Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's lecture topic is Coordinate Systems from Unit 1 Introduction. On completion, the students will be able to understand the different coordinate systems, explain about a rectangular coordinate system, and determine the dot and cross products of vectors. Coordinate systems. Coordinate systems are often used to specify the position of a point, but they may also be used to specify the position of more complex figures such as lines, planes, circles, or spheres. The choice of the coordinate system is based on the problem under study. Certain problems are solved easily by using rectangular coordinate systems, whereas certain others are not. Some coordinate systems make more sense, making it easier to describe a system. Coordinates give you a systematic way of naming the points in a space. A coordinate system defines points of reference from which specific vector directions may be defined. Depending on the geometry of the application, one coordinate system may lead to more efficient vector definitions than others. The three most commonly used coordinate systems in the study of electromagnetics are rectangular coordinate systems or Cartesian coordinates, cylindrical coordinate system, as well as spherical coordinate system. Rectangular coordinates. The rectangular coordinate system is an orthogonal coordinate system with coordinate axes defined by x, y, and z. The coordinate axes in an orthogonal coordinate system are mutually perpendicular. By convention, we chose to define rectangular coordinates as a right-handed coordinate system. This convention ensures that the three coordinate axes are always drawn with the same orientation, no matter how the coordinate system may be rotated. If we position a right-handed screw normal to the plane containing the x and y axis and rotate the screw in the direction of the x-axis rotated towards the y-axis, the direction that the screw advances defines the direction of the z-axis in a right-handed coordinate system. This diagram represents component scalars as well as component vectors in a rectangular coordinate system. Given an arbitrary vector E in rectangular coordinates, the vector E can be described using vector addition as the sum of three component vectors that lie along the coordinate axis. So E can be represented as Ex plus Ey plus Ez. These component vectors can be further simplified by defining unit vectors along the coordinate axis. Each of these unit vectors have magnitudes of unity and directions parallel to the respective coordinate axis. The component vectors can be written in terms of unit vectors as follows, which is given as E is equal to Ex plus Ey plus Ez, termed as Ex multiplied by Ex cap plus Ey multiplied by Y cap plus Ez multiplied by Z cap. Thus, using component scalars, any rectangular coordinate vector can be uniquely defined using the three scalar quantities that represent the magnitudes of the respective component vectors. To define a unit vector in the direction of E, we simply divide the vector by its magnitude, where the magnitude of E is the diagonal of the rectangular volume formed by the three component scalars. Dot product, which is also called as scalar product. The dot product of two vectors A and B is defined as the product of the vector magnitudes and the cosine of the small angle between them. And it obeys commutative law. AB can be written as BA. The dot product is commonly used to determine the component of a vector in a particular direction. The dot product of a vector with a unit vector yields the component of the vector in the direction of the unit vector. Given two vectors A and B with corresponding unit vectors A suffix A and A suffix B, the component of A in the direction of B, that is the projection of A onto B, is found B evaluating the dot product of A with A suffix B. Similarly, the component of B in the direction of A is found evaluating the dot product of B with A suffix A. The dot product can be expressed independent of angles through the use of component vectors in an orthogonal coordinate system. The dot product AB, product of like unit vectors, yields 1, while the dot product of unlike unit vectors yields 0. Cross product. It is also termed as vector product. The cross product of two vectors A and B is defined as the product of the vector magnitudes and the sign of the smaller angle between them with a vector direction defined by the right hand rule. Using component vectors, the cross product of A and B can be written as given here. A cross B is equal to AX x cap plus AY y cap plus AZ z cap cross product multiplied with Bx x cap plus By y cap plus Bz z cap. The cross product of like unit vectors yields 0, while the cross product of unlike unit vectors yields another unit vector, which is determined according to the right hand rule. Quiz questions on coordinate systems. List the different types of coordinates. Give a note on rectangular coordinates. Write down the resulting expression for vector product of two vectors. Thank you.